We're going to look at now at what are called rational exponents and solving equations using rational exponents. And a rational exponent is any exponent that can be written as the ratio of two numbers, two positive or negative, two integers, positive or negative whole numbers. So we see that this is the ratio of a 2 and a 3. We're going to look at some of these decimal ones, but these decimal ones can also be written as the ratio of two whole numbers, two integers. 1.9 over 1 could become 19 over 10. 0.75 could become 3/4. 2.4 over 1 could be 24 over 10 or 12/5. So all of these could be written as a ratio of two integers. Now, how do you solve an equation using rational exponents? There are two strategies. I'm going to recommend one as being the most efficient for the most problems, but there are actually two ways you can do some of them. So x to the 2/3 equals 3/5. So one method I could use would be to rewrite my x to the 2/3 using a radical. So remember that the 2 is the power and the 3 is the root. So this is the cube root of x squared equals 35. Now to undo, I'm going to have to undo two operations, the cube root and the squared, the power. So the first thing I'm going to do is raise both sides to the third power, because the third power is the inverse of the cube root. And so if I cube a cube root, I just get what's inside. So I end up with this is x squared equals 35 cubed. And I'm not going to bother to calculate that right now. It's not really necessary. Then I need to take the square root of both sides to undo the square. But since I am taking an even root, I have to remember that there are two possible values for x that could give me a positive 35 cubed, one positive and one negative. So x has to be equal to plus or minus 35 cubed. So x ends up being plus or minus, if I take the square root of 35 cubed. So that x ends up being plus or minus 207.06. So if you do plus or minus the square root of 35 cubed on the calculator, that's what you get. Now there's another way to do this problem, and that is by not changing it to a radical, but leaving it as a rational exponent. So I have x to the 2/3 is equal to 35. And I want to have x to the first. So what could I do with exponents to get from x to the 2/3 to x to the first? One way is I could multiply it by some power of x that would add together to give me x to the first. But that would, if I do that, then I would have an x on both sides. That wouldn't be helpful. So what I'm going to do is I'm going to raise both sides to a power that would make the x to the 2/3 become x to the first. Well, if I multiply 2/3 times its reciprocal, 3/2, then I get x to the first. So x to the 2/3 to the 3/2 power gives me x to the 2/3 times 3/2, and this is 35 to the 3/2 power, and that gives me x to the first. So x is equal to 35 to the 3/2 power. And think about 35 to the 3/2. It means I'm cubing it, then I'm taking the square root. Well, isn't that what I just did here? I cubed it right here, then I took the square root. But since I am doing an even root here, I need to remember plus or minus. So x is equal to plus or minus 207.06. So this is an even root. It's an even root. So I have to remember when I have an even root, when I apply an even root to both sides of the equation, I have to remember that there are two possible solutions. Okay, so let's look at this one. Now on all the rest of them, there are additional numbers in here. We have a coefficient here and here. We have something in parentheses here and a number outside the parentheses, and here we have something added outside the parentheses. So whenever we're solving a problem involving x raised to a power, we want to isolate the base with the exponent first. So let's go through and think about what is the base of the exponent. The base is the quantity to which the exponent is applied. So in the first equation, it's just x. In the second equation, it's just x. The 2 is not affected by the exponent. The 40 is not affected by the exponent. In example 4, it's 2x plus 3 that is the base of the exponent, because that whole quantity is affected by the exponent. And in example 4, it's the x minus 3 that is raised to the exponent. So we always want to undo everything else in the equation until we get down to just the base with its exponent. Then we can apply reciprocal powers. So the first thing I want to do on this one is divide by 2. So I end up with x to the 1.9 power is equal to 25. Now I want to apply reciprocal powers. Now I could write this as 19/10ths and then do 10/19ths, but I could also just do 1.9 over 1, and its reciprocal is 1 over 1.9. So I can apply this reciprocal power, 1 over 1.9, to both sides. And on the left-hand side, I just get x. Now, is this denominator an even root? No. Because even if this were 10/19ths, the 19th is not an even root, so I don't have to do plus or minus. If I do 25 to the 1 over 1.9 power, and just to show you how to do that on the calculator, it's just 25, use the caret symbol, and then do 1 divided by 1.9. Just make sure that all stays in the exponent. And there's my answer, 5.44. And usually I round it to 3 decimal places, so 5.442. 5.442. Now, you can also always check your answer. I can go back and say 2 times in parentheses, or actually I don't even need the parentheses, so 2 times this number raised to the 1.9 power should give me 50, and it does. Okay, so I can always go back and substitute that number back in for x in the equation. Okay, example 3. Once again, I need to isolate the base, so the first thing I'm going to do is divide both sides by 40. So I'll just go ahead and do like this. So I end up with x to the negative 0.75 power is equal to 8 over 40, which is 1/5 or 0.2. So if you want to, you can do that, or you can just leave it as 8 over 40. It really doesn't matter. Now, what's the reciprocal of negative 0.75? 1 over negative 0.75. So if I raise both sides to that same power, I would end up with x, and I'm gonna write this one more time, but I'm not always gonna write it like this, negative 0.075 raised to the power of negative 1 over 0.075, let me try this again, to the negative 0.75 raised to the 1 over negative 0.75 power equals 0.2 to the 1 over negative 0.75 power. And so now x is equal to, now let's think about this here. This was, I could also write this as negative 3/4, so its reciprocal is negative 4/3. So this power, notice the denominator is not an even power. It's not an even root, I'm sorry. When I raise both sides to the same power, that power doesn't have an even root in the denominator here, so I don't have to use plus or minus. So 0.2 to the 1 over negative 0.75 power turns out to be 8.549. Now, next two problems just involve an extra step or two, but they're basically the same idea. I need to isolate the base. I cannot distribute 4, remember, because there's an exponent here, and the exponent takes precedence. So it's on this type of a problem, you just want to divide by the coefficient here. So I'm going to divide by 4 on both sides. And so I have 2x plus 3. I think I'll write this farther over. My writing is big with my fat pen here. 2x plus 3 to the negative 5/2 power is equal to 7/4. So to take that to a reciprocal power, I'm going to have to raise both sides to the negative 2/5 power. So we end up with 2x plus 3. Negative 5/2 times negative 2/5 is just positive 1. So 2x plus 3 is 7/4 to the negative 2/5 power. Well, what is... I could go ahead and calculate that number if you want to, and maybe I should. But all I'm going to do now is subtract 3 from both sides and then divide by 2. I don't want to divide by 2 first. You always want to work from the outside in when you're solving from x. So we have x is multiplied by 2 and add 3. So we're going to start by subtracting 3 and then divide by 2 to get back down to x. So if I want to go ahead and take this number, I can. This is not necessary. I can do this all at once at the end if I want to. Okay, to the negative 2/5 power. I'm going to do a control enter to get the decimal value. So 0.7994 ... So 2x plus 3 is equal to 0.7994 ... I'm going to continue with the whole number, copying and pasting it down. Subtract 3 from both sides. So when I do that on my calculator, minus 3. So I get this answer, minus 3, and I get negative 2.20056. So 2x is equal to negative 2.20056. Double check that I wrote that correctly. Yep. And then divide everything by 2, which you can do on your calculator. When you do that, you get negative 1.10028. Once again, when I raised both sides to the power, I raised both sides to the negative 2 power and then use the 5th root, and this is an odd root, so I don't have to use plus or minus. Okay, last example here. To isolate the base here, I'm going to need to subtract 5 from both sides to start out with. So I have x minus 3 to the 2.4 power equals 10. So subtracting 5 from both sides. Now I need to raise this to the 1 over 2.4 power to use the reciprocal powers. Let me just write an extra line. I think that would be helpful. No, I can scoot it down a little bit and then just stick that in there. I know you guys can't do that, but there we go. And this is 1 over 2.4, 1 over 2.4. And so I end up with x minus 3 on this side. Now I have to decide whether I need to plus or minus here. So this is 1 over 2.4. This looks like it may be an even power or an even root down here. So I could rewrite this as 10 over 24, which is 5 over 12. So basically when I'm raising it to the 1 over 2.4 power, I'm raising it to the 5/12. So power is 5. That's an odd power, but it's an even root. So if I have an even root here, that means I have to use plus or minus because I am applying an even root to both sides of an equation when I'm solving. So when I'm solving an equation and I use an even root on both sides of the equation, I have to use plus or minus. So plus or minus 10 times 1 over 2.4. So that means when I add 3, x is equal to 3 plus or minus 10 to the 1 over 2.4 power. So I'm going to have two solutions. X equals 3 plus 10 to the 1 over 2.4 power, or x equals 3 minus 10 to the 1 over 2.4 power. So if I calculate both of those numbers, I end up with x equals 5.6101 or x equals 0.3898. So there are two solutions to this equation. So just to help you with that, when do we use plus or minus part? If the exponent can be written as a completely reduced fraction with an even numerator, then when you solve, the denominator is going to have an even root. Okay? Then you will have both a positive and a negative solution, because you will need to solve using an even root. Okay, so if the exponent, this is the original exponent, can be written as a completely reduced fraction with an even numerator, this is the power. Okay, so think about this. If we go back here, number 1, this is even. So I had to use plus or minus because when I applied the reciprocal power, it had an even number in the denominator, meaning I had an even root when I was solving. This is 1.9 over 1, or 19 over 10. So this is an odd power, so when I solved it, I had an odd root, because when I did 10 over, this would be 10 over 19, this would be an odd root. This one is negative 3/4, it had an odd power, so when I solved it, I had an odd root, so I didn't need plus or minus. This one had an odd power, so when I solved it, I needed, or sorry, this had an odd power in the original exponent, so when I solved it, I needed an odd root, so I didn't need plus or minus. This one, 2.4, was 24 over 10, which is 12 over 5, so it had an even power to start out with, meaning I needed an even root to solve, so I needed the plus or minus here. So I know that's kind of confusing that I gave you all the examples talking about the even number in the denominator, but that means when I take the reciprocal, I have an even root, which means my original exponent has an even numerator, which is an even power. So if the original exponent has an even number in the numerator, then when I solve, I'll need an even number in the denominator as a root, and I'll have to use plus or minus. So hopefully that makes sense.